Okay, welcome back. This is our third episode where we're building a game for the NES, a shoot 'em up. We have had two prior episodes, one where we did an introduction to the NES hardware, and then the last one, we had some weird issues with my PC, but what we streamed was moving the code that was in the vblank interrupt, which is now just this little bit of code here where it actually updates the PPU, and move the code that was doing all the game engine logic out of there and into the main execution loop that occurs after we do the initialization. So starting here in this game loop. So last time when we ended, we were having a problem where the sprites weren't getting updated properly. We were seeing this weird issue where basically sprites were sticking on screen, and so I think this will reproduce it because that's all the problem was. So if we go back to here, and it's not doing it this time anymore. There were a couple of issues. The first was that it wasn't initializing the Y here correctly. The second part was because of that not being initialized properly, it was creating some weird issues where it was then iterating through sprite mem incorrectly. And so if you recall from the previous episode, I ended with two different versions of sprite mem and sprite mem VB for the vblank version. That turned out to be totally unnecessary just because basically the issue was with the Y indexing and not with anything else. And so by fixing that, we were good. So that looks pretty good. That's I mean, again, we really haven't changed anything in terms of the core functionality, but we moved everything out of the vblank and into the main game loop with the vblank only handling the drawing functionality. Right? So if we go here, now we have all of our code for the entities working properly, so you can see it's updating these sprites here correctly, and the button presses are registering as expected in this variable here. So there were a couple of things I wanted to clear up from last time, because looking back at the video, I realized one, I stated something that was kind of not possible, and not the smartest thing to even think, but it was just because I think I was tired and confused by the error we were seeing. And so thinking out loud, that's the thing when you're streaming and you're programming. For me, I'm just kind of thinking out loud as we do this, and so sometimes your brain goes into weird places trying to figure out what the problem is. And so I don't try to limit myself to thinking about all the things that it couldn't obviously, let me rephrase it. There are a lot of times when you're programming and you're like, oh, it's obviously not that's not possible. But what I've found is that a lot of times when you think that's exactly what it is, right? So the thing that you're saying, oh, it could never be that's impossible, turns out that's exactly what it is. And so, I've kind of over the years trained myself to allow my brain to kind of wander into those sometimes nonsensical crevices of thought where, you're trying to figure out what could be wrong with your code. And so during that process, I was wondering if the vblank code was actually running parallel to the game loop code, which obviously isn't possible. I'm not sure what the deal was with my thinking there. It was just, again, kind of going through and trying to figure out why we were experiencing this weird problem. And the reason that I thought it could be, this actual parallelism is because it was exhibiting behaviors similar to when you're doing any sort of multi-threaded coding and you have code that isn't thread safe, right? So you have one thread executing somewhere, doing something and changing data while another thread is executing and updating the same data in the same memory location, and you run into strange behaviors that shouldn't be possible but are as a result of the fact that you're not using thread safe code, or you're not locking your data structures, or you're not using critical sections, or whatever the case may be. And so, it was similar to that kind of concept, but it turned out to just be that I wasn't actually saving all the state that I thought I was. What I needed to do for that was all of these pushes onto the stack, and then the pulls at the end of the VBlank. So, that's what the thinking was there. It was just me kind of thinking about how we could be experiencing this problem, right? Because it was looking at this location in memory and comparing it to see if it was 1, and it was, which should have been possible, right? Because we weren't actually changing that variable anywhere in the VBlank at the time. So it was kind of like, how is it possible that it was actually calling this jump? And what it was it was loading draw complete into A, and then the interrupt was occurring and running, and then when A came out, when the interrupt completed and it came back to this, sometimes the value of A was 1, right? And so the value of A being 1 was all it took for it to then continue on and set draw complete to 0 and then jump to the top of the game loop. So very weird behavior, but obviously not running in real parallel. It's being interrupted, hence the name, interrupt. It's actually stopping your code from doing whatever it was doing and going to a totally different location, in this case the VBlank, right? The second part that I did actually a bad job explaining, and part of it was because I was trying to remember what it was I even was doing here, and I was confused by some of my labeling, and this is because this code was written while I was just kind of figuring out how to get all of this initialized. Was this part I was talking about, how I figured out that it's related to the palette functionality, right? And I kind of vaguely explained it. I just wanted to cover that again because I feel like I did a bad job explaining that last time. So if we go to the reference here and you look at the PPU, no, I don't want to go to the actual palettes. I want to go to the memory map. Yes. So what I was saying was that I wanted to change a specific location in memory in the PPU because that location directly mapped to the palette of the display. So what I was saying was that it would set the address and then change the color, and I was kind of vague about how that all worked. So I want to go into more detail about that. So the way that works is when you want to update the palette, and we did this before too, if you remember. Where is it? Here in the palette load. The first thing you need to do is you need to read from this 2002 address in memory. Okay? And what that's doing is it's telling the PPU that you are going to write an address. So if you look at it, it says the status, read, right? You're going to read it and you're going to tell it, and that's basically telling it that you are going to write an address into the 2006 register because you want to load the location of the address with specific data. So what I mean is when you read 2002, you're telling the hardware, okay, get ready. I'm going to write 2 bytes into 2006. Okay, and 2000, so what I ended up writing here was 3F17. If you look at the, where is the memory map? If I go back to the memory map, the 3F to 3F1F range is the palette. Right? So I was writing 3F17 because I was getting a specific location within this memory. And what you do is you write the address, the high byte first, and then the low byte, into the 2006 register. Right? And so you can see it's actually doing that in this example where they're writing the address 2108. And then once you're done, you write the value that you want to store at that location in 2007 in this address. Okay? And then that will, after that write occurs, it increments the memory address that you had written in this case the 3F17, by an amount that you've configured. In this case, we don't care what that increment is because we're just writing one palette value, because we're literally just taking the value of h swap h and writing it into this 2007 register to update this particular uh-oh. What is going on? It's the mouse? No, it's the Bluetooth. Okay, so apparently you shouldn't use this TrendNet Bluetooth device because it is garbage and locks up your machine. All right, well, sorry about that. So what I was saying was, if you look at the PPU viewer, you can see this location in memory is being updated in the palette, and that's all that this is doing. Okay, hopefully that's more clear. We're going to switch to keyboard, I guess, since my Bluetooth adapter is junk. This will be the third time I'm remapping things tonight. Cool. Okay. Great. So hopefully all of that is clear. I'm looking to see if there are any questions in the chat. Doesn't look like it. All right. So what are we doing next? Well, I wanted to, now that we've gotten this working, and we've discussed the things that I hopefully didn't too thoroughly confuse, I wanted to add a new entity type because this game is pretty boring if there are no enemies in it. I'm going to rename this flyby type. Well, we'll call it flyby. That's fine. And we're going to add the ability to create one of those guys by checking the B button. All right. So let's talk about this for a second. One of the things that I added here was a little bit of code for the A button. And the reason I added that code was because if you just look to see if the A button was pressed and then took action, what you end up with is you end up with, for example, the bullets firing based on the A value would just keep firing continuously, right? Because if A is pressed down, it would just simply add a bullet and the end. It would just keep doing that over and over until we ran out of entities, and then it wouldn't be able to add any more. But I didn't want to do that. I wanted it, you have to press the A button repeatedly, and each time you press it, it only can possibly create one bullet. So I added just what I call the button flag, and it's literally just a byte that when you press the A button, sets the first bit, stores it in button flag, and jumps to finish controls. Now, if it comes back through the loop again and the button flag is set, it's not going to consider that the button was pressed. It's basically considering it that the button wasn't released. So let me clarify that, because that was probably a confusing way to explain it. So it loads the controller variable, right? It looks for 8, which is the highest bit, which is the first button, A, because the order of the buttons is A, B, select, start, up, down, left, right. And we're shoving those all into a single byte. So if you remember from the first stream, we talked about that a little bit. If this is your byte, 1, 2, 3, 4, 5, 6, 7, 8. Right? If this is your first byte, we're basically pushing the single bits that we read from the controller latch so that it's 1 bit per button. Up, down, left, right. So we do a bitwise AND on the controller value, and if it's equal, that means that the value is 0. So really quick, I just noticed that this is spelled wrong. Real quick, if you the way that most processors do things like check equality is it takes the two values that you're looking at and it subtracts them. So if you're saying load A some value like from this address 1000, right, just as an argument's sake, and then you say compare the value 50, it basically subtracts those two things, and it then checks to see if the value is 0 when you do branch equal, right? So it's looking for the 0 condition from the subtraction of those two of the comparison operator. If it's not 0, then it would be not equal, and then some processors have the ability to do jump greater than, jump less than, based on other flags that get set when you do those comparisons. But the 6502 just has the equal, not equal. It has plus and minus too, which can be used for the same thing as less than and greater than, but I don't want to get into that right now. Basically, all we care about is that we're doing the comparison of, if you think about how binary works, right? This is 1 byte, or sorry, one digit of the hex value. It's a crappy line. So this is 1 digit of the hex value, pound. So 8, 0, right? So this is 1, 2, 4, 8. So each of those bits can set this value to this digit to one of those values. Same thing for this. So we want to check against 8. So we do the logical AND, or sorry, the bitwise AND, and if the 8-bit is set, then we're going to get a non-zero value. If it's not set, we're going to get a 0 value, and then we're going to go to check a release, right? So if the button is pressed, we skip over this, we load the button flag, we apply the 1 bit to it, we store it back because we're done. The reason we're doing this is because I could have incremented it, but then it would just keep incrementing it every time it comes through and the button is pressed, and I want that bit to be specifically set because I wanted to use this button flag for other buttons, which we'll do in a second. And then it stores the button flag and jumps to finish controls because it's skipping this portion where it's adding the bullet to entity memory, which is here, right? If it comes in and the button is no longer pressed, it's going to get the 0 value, which means the branch of equal is going to take the branch. It's going to check a release. It's going to load the button flag and compare if the button was pressed previously, which means that button flag would be set to 1. And again, if it's 0, then or in this case, if branch of equal is satisfied, it will go to finish controls because we don't want to add the button because the button wasn't previously pressed and it wasn't actually released. It was just not pressed, period, right? So between the two runs through there was no press and release. It was just simply never pressed from the perspective of our previous check. And if it's non-zero, then we're going to decrement the button flag. Realistically, we want to do the exclusive OR on this to turn the bit off properly rather than doing the decrement. So let's do that here. So we'll load a button flag EOR. So that's an exclusive OR on the button flag. We're going to do it for 1 and then store button flag. And just real quick review for those of you who don't know or don't remember. Exclusive OR, if you were to do a little truth table of that for 1 bit, right? So exclusive OR looks like this. If it's true and true, you get false. If it's true and false, you get true. If it's true and false, you get true. If it's false and false, you get false. That's opposed to regular OR. So this is XOR or EOR. For regular OR, bitwise OR, if it's, you have your truth table for that, right? It's true and true gets true, true and false gets true, true and false gets true, and false gets false. So the big difference is that you can't have both of them set to true. That will then make it false. So that's good for turning bits off in a situation like this. So that's what we're doing here. Okay, so the next part we want to do is I want to add a check for the B button. So I'm going to load the controller variable. I'm going to compare it against 440 hex because that's the B button. It's the second highest bit in the byte. If it's equal, then I want to call something called, I want to go to check B release, right? Because I'm checking to see if the B button was released. Otherwise, I'm going to load the button flag. I'm going to OR bit 2 because I need a separate bit for the B button. And then, I mean, it's basically the same thing as the way the A button check works, but with the difference is that I'm not jumping to finish controls, right? I don't know why I just typed that. Probably because I was saying it. I want to check A because I want to do the check for both of them. And then check B release. I'm gonna load the button flag. I'm gonna end it with 2. So if it's not set, we're gonna go to check the A button, which means it wasn't released. It just wasn't pressed in the beginning to begin with. And then yeah, and so then I'm going to load the button flag again. I'm going to exclusive OR the second bit to turn it off, and store it, and jump to, for now, I'm going to jump to add bullet because I just want to test that this is working the way that I expect it to, and then we'll try and add the new type. So that's the, okay, so both the A and the B button do the same thing. If I go to the hex editor, so our control variable, you can see that's stored in this byte, and then which is the, okay, and then the button flag is this byte here. So if you watch it, when I press the A button, it's set to 1, and until I release the button, it doesn't fire, right? So the B button, same thing, setting the byte value to 2, and then when I release it, it goes back to 0 and actually fires the button. So you can fire a little bit more quickly. Oh, I don't know why. Just press the Q button accidentally. Q key. Okay, so that's good. That's working. That was pretty straightforward. Great. So now let's add something else. Let's add an enemy. So, right, because that's what I call them, that'll flyby. Okay. We'll just make this a simple enemy that just kind of starts in a location and continues down the screen. So the first thing I need to do is I need to iterate through the existing entities and see if there is a free spot to create this enemy in memory, right? Because we only have so many spots where we're keeping track of the enemies, or actually anything in the system, the player being one of those entities, bullets being another set of those entities. I want to add the flyby type, the flyby enemy, into that location in memory if it's a free slot. So this is going to be the same code essentially as the add bullet. So we're going to say add flyby loop. We're going to load X to initialize it. We're going to compare it to the total number of entities minus the size of entity. And the reason we're doing that is because if we're at the last, if X is at the last possible position, we are finished. That's interesting. Why? I don't think that's right. I think that may be wrong, because realistically, if we have 10, we'd still want to go to the last total and the total entity, right? We'd want to go all the way to the end. Maybe we have an off by 1 error here. Let's try an experiment. Well, let's do this first. So I'm going to comment that out because we're not going to do anything with that yet. Let's change the number of entities to 2. So in theory, what should happen now is I should be able to just get 1 bullet. But what I'm thinking is going to happen is I'm not going to get anything. Oh, that doesn't do anything. That's not connected. Yeah. See, I'm not getting anything, and it's because I just have a stupid off by 1 error. So if I go back to here, this should be this, and I put that note because originally I think I was having a problem where it was going past the end and things weren't behaving, and it was because I was doing something else wrong. So let's go back to this and change total entities back to 2, or max entities to 2, I should say. Rebuild that. Yeah, see, so now I can only add 1 bullet. If you go to the hex editor, you can see there's just the one sprite location here. And this is the FFFF is the X and Y, and the 0 is the fact that it's not, there's no entity right now. And you can see as I move the ship around, these other bytes are moving. This is the X, the Y, and then the player entity, which is 1. And I fire the bullet. So it's cool. You can see that play through as you're moving around. So, all right. So that answered my question. That was just a bug from, I don't know, from messing around with too many things at once, or not sure. Okay. So I don't want to do that. I just want to do compare to total entities. If we've hit the top, then so if you compare X to the total number of total entities, and it's the same, then we're going to branch to finish controls because we're done trying to add it to the entity list. So entities plus entity type X. So we're again iterating through the entity list by saying here's my entity memory, here is the offset to the type value, and then here's my index. So compare it to no entity. So see if it's the no entity type, which is 0, and if it is, then we're going to say add flyby entry. Otherwise, we're going to transfer X to A, clear the carry, add size of entity, so we can increment X. So we're incrementing X by the size of the entity through memory, right? Because if you look at the memory, right, if this is our memory that has the entity list, you have the X, you have the Y, and you have the type, X, Y, type. And all of that is one entity. And then we have X, Y, type, and then X, Y, and type. Right, and so on and so forth for the maximum of entities. So X starts here, and then we do X plus 3, and then X plus 6, and so on and so forth. And that's what that's doing here. It's saying to increment. Well, in this case, what it's doing is it's transferring X to the accumulator. It's clearing the carry so that it can do the add properly. It adds the size of the entity to the accumulator, and then we're going to transfer. What do we? Yeah, and then we're going to transfer A to X because we want X to reflect that change, and then we're going to jump back to add flyby loop, right? And then realistically, you know, this could probably be streamlined a little bit. Right now, I'm just kind of kludging this, but realistically, the only thing that's different, well, maybe we'll do that. The only thing that's different about how each of these works is the type of entity that you're dealing with. It doesn't really make sense to... No, there's a difference too with the way when you add the bullet entity, you can see here it's adding 4 to the X position. It's taking so the first entity, right? It's taking the first entity's X position, which is the player's X position, and adding 4, and then storing it in the X position of the new entity that's being created, and then it's taking the Y position of the player, and then adding that to the or storing that in the Y position of the new entity, and then giving it the bullet. So there are a few little minor differences. I still think we could probably consolidate this into a single thing, but let's just get this working for now, and then we can refactor this code. Sometimes it's better to get it working and working the way you want, and then look back and refactor it instead of trying to refactor it and write it at the same time. Now, you know, I'm not saying we should add 20 things and do that. I'm just saying for now, rather keep it simple. All right, so we're going to add the entity here. And then, so, okay. When it's done, we're going to do finish controls. But, well, so let's just start off with, let's make it get created right where the player is, right? And we're not going to change the X position at all. We're just going to store it in directly. Now with the Y, I want it to start at the top of the screen, so that's the 0 position, and then I want to store that, and then we need to not type Y position, and then for the type, it's entity type flyby, and then we'll store that in the type location in memory. All right, so now what we should get when we hit the B button, well, we're going to get nothing, because even though we're adding the entity to memory, we don't have anything in the VBlank to handle that type, right? If you remember, we have these checks here. So compare entity type flyby branch of equal to flyby. Okay. So just to keep it simple, I'm just going to copy this. And again, I think there's probably some consolidation we might be able to do to reduce the code required, but maybe not. I mean, this is literally just because I'm making it be the same as a bullet for the purposes of just checking to make sure that we got this working. Symbol flyby is undefined. Flyby sprite. So 473. Capitalization matters. All right. So now this should just create a sprite at the top of the screen. It's not. X editor. Let's reset the NES. Okay, so it's creating the entries. Oh, you know what it is? It's because if it's too close to the top of the screen, the NES won't render it. So 0 is a bad choice for that. So that's a little tip. If you want a sprite to disappear, you put it at the top of the screen and you can't see it anymore. Where is that code? So let's make it at 8 and see if that works. So there it is. Okay, so that's our flyby. It's not doing anything because we don't have any logic in the game engine that processes that. So if we go to look for where is it? Here's process bullet. Compare. Okay. So let's see about this. So what I think I want to do, is I want to, instead of making it fall through, I want it to jump to the location to process the bullet. Oops. All right, so then, you know, I don't remember if I have to reload. I think I have to reload A, but I'm not sure. Well, we'll find out soon enough. Process flyby, otherwise jump to skip entity. So all I did was, instead of it making it fall through if it was not if it was equal and going directly into process bullet, I instead change it to say, okay, if it's equal, go to process bullet, otherwise it compares to flyby, and then if it matches, it's going to process flyby. This is going to jump to entity complete. This is also going to jump to entity complete. And then here, what I want to do is I want to process the bullet. So, the flyby. So basically, the way I was processing, okay, yeah. So I just want this to right now move from the top of the screen to the bottom of the screen. And so it's going to start at the 8 position, which is the top. And it's going to move down the screen by incrementing. We're going to increment by, let's say, 2. So I'm loading up the Y position. I'm clearing the carry. I'm adding 2. Storing it so that when the VBlank occurs, we will get the proper location. And then I guess what I want to do is I want to compare it to some reasonably large value. I mean, ultimately, we're going to want to do collision detection and stuff like that, but let's not get ahead of ourselves here. What I want to do is make sure that this is working as expected. So, all right, so I don't know what's a good value for the bottom of the screen. FF. So let's do FE. So if it hits FE, if it's not equal, then entity complete. Otherwise, basically, if it does that, if it hits that, we're gonna initialize this guy. Right? Again, this initialization probably could be done a little more efficiently, where we are not literally copying the code that is happening above, but for now, just want to get this working, and then what we can do is we can look at how we can make this happen. Because the thing is that storing, let's see, clearing the entity from memory, yeah, that could be the same for both. And the X wouldn't change. Let's do that. Let's do that. I think that's probably not a bad thing to streamline, so we don't have to do that both times. So we'll do that right here, clear entity. And we know that when that's done, it should jump to entity complete. And so realistically, we don't care about any of this stuff other than that the X value is preserved, because when we jump to clear entity, it's going to need the X value to be able to change the value of the entity, right? So entity complete, skip entity. Okay, and that's good, because at this point it's going to use, okay, yes. So process flyby, same thing here, branch if not equal to entity complete. Otherwise, we want to jump to clear entity. So there we go. We have fewer instructions because we're consolidated that down. That's pretty straightforward. No reason to be, there's no special cases where we need to do anything different. We just want to initialize that back to a clear entity state. Unexpected trailing garbage. Right, you don't need a colon there. Okay, so processes the flyby. All right, so cool. So we're just taking the Y position, adding 2 to it, storing it back, comparing it to see if it hit the FE location on screen, and if it didn't, we go to the complete portion where it checks to see if there are any more entities to process. Otherwise, we're going to jump to entity to clear the entity. Now this should be, let me just make sure I'm doing this the right way. We have a way of computing this now based on the total entities. Where is that code? This should just be total entities times, I think that's the right syntax for that. Right, we don't need to be hard coding that in, because if we change the number of entities, we want to be able to ensure that we don't have to go change it in a bunch of places. I did that right? So it's 3 times 30. Yeah. I don't even need to calculate that. That's right. Yes. Assuming that I did that operation correctly, we can get rid of these no ops because we don't need them anymore. They were there for. I didn't mean to do that. We don't need those. That was more for debugging purposes. Okay, great. Build that built. Hopefully we didn't break anything. Okay, so our entities are presumably working because bullets are spawning. If you go back and look, when we spawn the bullets, you can get to the last one there by pressing the key really fast. Okay, and then if we press the B button, there's our flyby. And okay, cool. So that's not bad. That's more or less where I wanted to get. I'd like to get to collision detection, but the last 2 streams ran really long because I was running into weird issues, and I'm debating if I should continue on. It'd be nice to get the collision detection part working. Well, you know what? For a change, I'm going to end it a little bit early. We accomplished a pretty concrete goal from what I wanted to do in the beginning. We will cover collision detection properly in the next stream, because what I wanted to do is make sure that, we could implement a pretty naive collision detection strategy for the bullets and the enemies, and that would be okay. I want to do a little more research before I settle in on that, and we get an efficient way of doing that. I mean, the inefficient way would be good in the sense that it's simple to do, because essentially you're just checking to see if I've got, my bullet that's in this bounding box, and I've got my ship that's in this bounding box, right? Obviously, I am not an artist. Do they overlap, right? And basically, the stupidest, naive way to do that is you check to see, okay, first are the X values of this within the X values of that, and then you can do the same thing for the Y. But I feel like there's probably a better way to do that, and given that the NES isn't really super powerful, I don't want to implement the most expensive way to do it, unless there's no other choice, or that turns out to be a decent way to do it. Just want to check the stream here again. Yeah, so I think that's good for now. As always, if you want to reach me, you can leave a comment on the video on YouTube. These all get posted to YouTube. If you want to reach me on Twitter, I'm at Clarvis. I believe you can leave comments on Twitch. Yeah, and I'll see you next time. Thanks for watching.